Hi, my name is Gilles, and today we'll be discussing a hockey stat that we all know, but for some reason never talk about. Or at least we'll be doing an initial exploration of a hockey stat. Specifically, the duration of a game segment. Now, a game segment, I use that as a term to define the time between the puck drop and the whistle. So it's the duration of play. And I find it interesting that it's an absolutely fundamental unit of time within hockey, but it doesn't even have a name. So that's how much it's been ignored. And today this is our quick plan. We're going to basically just crack open the black box, take a look inside, and see if we can identify any of the main moving parts. We're not going to look for any sort of deep insight, just sort of an initial exploration. So we'll start by getting a sense of the overall distribution of values. We'll establish a mechanism for evaluating different conditions and seeing how they impact the segment durations, whether something makes the next segment that's coming up longer or shorter. Then we'll pick some conditions, gauge their impact, and then we'll review what we found, a few footnotes and curiosities that we'll encounter along the way, and we'll sort of defer till later. My background is I got into sports software in the mid-1990s. And into the early 2000s, I did online sports data, games and contests. Hockey Stocks was one of them. The company got merged with Fantasy Sports Services and did that until the early 2000s. When I sold the company and was recruited by finance for some reason, did some fintech for about a little over a decade. I was a software architect doing financial risk analytics for Algorithmics, which was eventually acquired by IBM. And this is actually kind of relevant, while no sports at all involved in that. But when I first started it, the analytics there was very much like the analytics in sports. It was sort of a younger generation running around with spreadsheets, doing interesting things, an older generation that relied mostly on experience, and how that evolved was interesting. I think that in terms of analytics becoming more important within the thing is that's a foregone conclusion. It's a useful thing. And however, what I got to see was the evolution of analytics itself, like what a capital A analytics piece of software looks like, and once it's matured and is used sort of as a core component of the decision-making process. It's not going to factor into today. But since the left IBM in sort of 2015, 2016, since then I've been doing customized hockey tracking software, analysis systems for private concerns. But while I was working on that, I was also working on some private stuff, my own stuff, and that's nearly ready for release. And it basically does analysis of hockey games in real time. Anyway, what we're going to talk about today, though, is segment durations. And so here's the distribution of values from starting in about 2013 to 14, all the way to the present. I've graphed the durations on the x-axis and how many times they occur on the y-axis, and it looks like that. Apologies for the moire pattern. We won't be here long. One of the things that I think is notable is that there's a peak at the left, obviously. The most common one is 7 seconds, but that's about 2% of the time. And it sort of trails off, it goes off way to the right, and you wonder where it ends. It goes all the way up to 825 seconds is the longest one I found. 13 minutes, 45 seconds. We'll talk about that a little bit more later. But in terms of the curve itself, it really looks like a probability mass function of a Poisson distribution, which sort of in retrospect is sort of not all that surprising. The median is at 44 seconds, which is kind of an interesting number, since it also sort of is the idealized shift length. We'll come back to that, look at it, and see if there's sort of really anything there or not. Probably not. Also, I will note the average in sort of this kind of distribution. The average will fall to the right of the median. And so in this case, it's about a minute. And 50% of all segments will fall between 20 and 84 seconds long. And the 10th and the 90th percentile are 9 seconds and 136 respectively. We'll mostly sort of won't be doing graphs. We'll be using candlesticks and sort of just noting those 5 numbers. I'll augment it a little bit and include the average, although sort of we'll see that the average and the 50th percentile kind of move together. By season, starting in 2013-14 and going all the way up to today, today actually is sort of just through November 8th, game 178. But it's fairly consistent for the first 5 years, and then it seems that it's sort of there's a little growth spurt. I call it a growth spurt. And sort of if you look on the left-hand 5, they're absolutely remarkably consistent. And on the right, though, we see something starting to happen in 2018-19 and sort of continuing on. And if we want to sort of focus on just sort of what the changes are as we go along, I've sort of graphed in green positive changes and in red negative changes. And on the left, again, all gray, very, very few little changes, little jitter. But say 2015-16 and 16-17 are actually identical, right down to the average, to 1 decimal place. But it sort of starts in 2018-19, whatever it is. We don't know what it is, or I can't tell you. But something started there and then really got rock and rolling and continued on, like sort of grew. 2020 was a little longer than 2019. So whether it's continuing on today, I don't know. We'll find out more as the year goes on and we get more data. But I wanted to just focus for a minute on, we have a pretty good intuitive notion of what the median is. Sort of half of the values are larger than that, half are smaller. But just a little bit of intuition, to build a little bit of intuition about what the 75th percentile is. And sort of if we divide the season into 4 chunks where there's as many segments in each of the chunks, if items in the 3rd quartile grow and would move into the 4th quartile, what will happen is there'll be obviously fewer in the 3rd, more in the 4th. The curves will go down and up. But what will happen is the 75th percentile will move right to take into account that it needs to sort of have as many in the 3rd as in the 4th sections. So coming back here, we're seeing that a +3 on the 75th percentile tells us that from 2017 to 2018, longer segments grew even longer. And that continued to happen into the next 2 seasons. And the median grew as well, although not as much. So it was sort of basically just an expansion. And so having this realization that we have something happening impacts on how we want to measure particular things. If we want to apply a condition and see how it affects the segment durations, we kind of need to take into account this particular change that we're looking at. And so if we just did it naively and sort of had a baseline distribution of all 500,000 segments that go back to 2013, and we wanted to apply some condition to it, say sort of evaluating the short change versus the long change periods, well, we see that there clearly is some sort of impact that the long change has, that those tend to be shorter than the short change periods. In the graph, we're sort of looking at 2 things going on at once. One is whatever caused that growth spurt, and then we're sort of seeing through that murky lens the impact that the long change and the short change have. So going back to here, what we'd like to do is actually divide these into 2 groups. And I've put 2018-19 into the first group, and we're going to sort of treat these 2 groups separately. And I chose 2018-19 to be in the first group for rather not arbitrary reasons, but it was sort of whatever was happening hadn't fully happened yet. So, and also it makes it sort of 6 seasons and 3 seasons, although that's not as important. It's sort of some little symmetry. So what we'll do is applying again the sort of the long change, short change. What we'll be doing is applying it twice, once to the old regime and one to the new. And so we'll see it happen on the old data or the before data, before the growth spurt, and then after the growth spurt. And so now we can more clearly assess, we see the same thing, which is good, and actually having two of them provides us some sort of cross-check as we do this, that if we apply a condition and we see it both in the old data and the new data, since they're two completely separate data sets, it provides us some confidence that the effect is a real one. So let's start with even strength versus power play. This one I wanted to do first because it's the thing that most obviously might have an impact on segment length. And the expectation going in is obviously that on a power play, segments are going to be longer. That one team is controlling the puck, there's little opportunity. The whole idea is that there's little opportunity for the other team to impact play, and so the play is controlled in a way that should generate longer segments. So here, sort of the baseline is even strength, and if we look at the power play, what happens? We would expect it, and it does grow longer. What I did find surprising was how much longer. 14 or 15 seconds longer on average, or by median, over sort of even strength play. Now, the effect is so pronounced that in sort of looking at sort of doing further sort of conditions, we might want to take that into consideration, and rather than using the overall number of segments, we probably want to use the even strength numbers as our baseline. So all the conditions from this point forward will be based on or measured against or measured within the even strength data set, which kind of makes sense because, again, if we sort of have the overall one, we're sort of teasing two things apart. So the first thing I wanted to look at is does the intensity of play, and as a proxy I'll use just as a playoff hockey versus regular season hockey. So in the playoffs, does play get longer or get shorter? Going in, my guess would have been that playoffs would be longer. Players are more focused, one would expect, and that focus might result in fewer mistakes, and fewer mistakes might mean fewer stoppages. In fact, though, it's not big, but playoff hockey is a little bit shorter. And again, it's nice having the cross-check. The effect is small, but looking at the old data versus the new, the same thing happens. That it's like I said, it's fairly subtle, but it's definitely there. A little surprising. Sort of, what if we sort of double down and say, overtimes and finals? Sort of the same thing. Overtimes are probably more intense than the finals, just generally, just because next goal wins, and there's really literally no margin for error. Numbers get very small, and so we see that the overtime, the 90th percentile, just jumps up. But again, now we're down to 544 items. It's a far cry from the 500,000 that we started out with. So in some of these conditions, we get into some jitter caused by the fact that we only have a few instances to measure. But what about the absence of importance? Does that have an impact? So this is all segments that start out with the score tied. This is their distribution. What is the expectation as sort of the game gets more and more out of hand? So if the delta is 1 goal, 2 goals, 3 goals, 4 goals, 5 goals, what do we expect to happen? And surprised to learn that, in fact, very little happens. I expected that 6 is greater than 5, but really when you compare it to tied, it's not as big as an impact as I would expect to have, that you'd be expecting. People would sort of like, let's just play, let's get the game over, the refs just want to go home, so it becomes more of a run clock kind of thing, but not the case. What about sequence patterns? If we sort of measure one segment against the segment that precedes it, say if we sort of measure all the segments that follow a segment of 8 seconds or less, are they longer? So, but no correlation there. So basically, they're discrete things. So one segment has very little impact on the one that follows it. Perhaps patterns. I didn't look at patterns, like a short. Does that imply a long? Perhaps. And I didn't mention it, and I want to, is that being very preliminary here, I have a whole bunch of data. It's already been processed. If anybody wants to get in touch, I'll post my name and contact information at the end. If you want to get in touch, absolutely do. I'm happy to sort of share the data and sort of look to collaborate or just participate, be a shoulder to cry on, whatever. If you're interested in looking at this data and bringing it forward, I'm more than happy to help out. Give me a ring. So what about game situations? Kind of arbitrarily, I picked start of a period, used a baseline, a modified baseline. These are all the even strength starts, but without the period starts. So these are all the baseline where the face-off is not the first in the period, and measured against all the face-offs that are the first in the period. And I expected nothing to happen. And this is a fairly substantial change. This is just as much as the growth spurt against not a huge change, but one that's very real. As sort of it's sort of same in the pre-growth spurt, post-growth spurt. We see the sort of same thing, 4 or 5 seconds, 3 or 4 seconds. So something is actually happening there. And interesting question is what it could be. So might it be the fact that, the first face-off of the period is at center ice. So what if we sort of condition on center ice face-offs other than the period starts? What happens there? There is a growth compared to the baseline, but not as much as the start of a period. So the start of a period has some sort of impact on its own. Is it the fact that there's a discussion ahead of time? So this is what we want to accomplish in the first shift. Here's our starting 5. Would that have an impact? Possibly. I could see that happening. What if we condition and compare sort of short changes to long changes for the first drop of the period? We see the same thing. So now we've got 4 completely separate data sets. The bars on the very left within each segment are the short changes, first and third period. The long change in the second period, that's why sort of a 2-to-1 ratio there. And we see the same thing on all 4 data sets. It happens. So something about the start of a period causes segments to be longer. Will we see the same thing if we condition on the delay before a puck drop? So this is private data. We sort of, as a sort of function of doing other tracking, we get the delay between the previous whistle and the face-off. So they tend to be about 35 seconds a delay, and plus or minus. So 26 or less is a very rapid turnaround. And we sort of, went too fast. We sort of see it growing to 71, and which is kind of interesting. I've sort of done it just sort of to have equal numbers of segments in each column, and does it continue to rise? And so what I did was I split the 5th section into 2, sort of 120 seconds plus, figuring that that brings the TV timeout, and we get a fair number of those. So that's an opportunity, like the start of a period, to discuss what we want to do next. So if we pull out the 71 to 119s and the 120 pluses, we do see, in fact, that it does continue to grow. But what was hiding in the data was this weird thing. Like it sort of all of a sudden drops off significantly when the delay is 71 to 119. And one of the things that occurred to me was, could that be the team timeouts? That would be kind of interesting. Those there are fewer of them, and we're looking at smaller sets of data. But that's also obviously a team timeout is really a time to talk about things. So looking at that, isolating just slowly on the team timeout, this is not expected at all. There's a total collapse. This is sort of like an inverse, the opposite of having a power play. Play stops almost immediately. Like it's sort of a radically huge, in my mind, change. I find this very fascinating in that, sort of compared to the start of a period, you have an opportunity to talk about what you want to do in a general way. Television timeout, more of a rest period, probably some talk on the bench of sort of how things are going. But what's interesting is once the clipboard comes out, boom, don't have an explanation. So anyway, this is meant to be short and sweet. That's found a few interesting things. So it seems that segments get longer starting in the 2018-19 season. The long change in even numbered periods seems to make segments a little bit shorter, which is kind of interesting. Playoff segments are shorter than regular season segments, but not by a huge amount. Score differential doesn't seem to impact it at all. Power play situations, as expected, have a huge positive impact. And the duration of one segment doesn't seem to affect the following segments. And surprisingly, the segments at the start of a period are a little longer. And the longer the delay goes, the longer the expectation for the following segments, except for if a team timeout takes place, then times are extremely short compared to the baseline expectation. And again, anybody who wants to dig deeper and go further with this is absolutely invited to get in touch. Before we close up, though, a couple of footnotes. One is the stoppage in play. Again, sort of 5 equal sort of sets, segments that went up to 15 seconds. Which is really sort of play doesn't get underway. In looking at this data myself, I found I wasn't really paying attention to that first column. The next 4 are interesting because play has now had a chance to get underway, to develop, to actually become established. And what's interesting is how little the reason for a stoppage changes, which probably some, as we saw, this is probably some Poisson distributions, plural, going on. One thing that jumps out is offsides go down slightly, but probably not enough to really get incensed about. But penalties, the longer ones generate fewer penalties, or fewer of the longer ones proportionately end in a penalty, which I found a little curious. We won't get into refereeing. That's a different talk. Segment duration versus shift duration. We noticed some sort of correlation of sort of 44 being the overall median, and they just I think they happen to be in the same neighborhood. Although what's interesting is if you compare sort of the pre-growth spurt to the post-growth spurt, we see a lengthening in shift durations as well. It's smaller, but shifts in the last 3 years have gotten a second longer on the median and 1.4 seconds on average longer than they were. 45.6 in the old days, 47 now. And the obvious question is, what were the longest ones? So I picked out the top 20 that I could find in my data, and these are it. The longest one is the 13 minute 45 seconds is Washington-Pittsburgh in 2014. But notable perhaps is that the next three of the top 4 are ones that have happened in the last couple of years. So that's it for me. I hope there was something of a little bit of interest here to sort of spend time on in the afternoon. There's my contact information if anybody has questions, comments, or if you'd like to talk about sort of moving this forward, absolutely get in touch. Love to hear from you. Have a great day, and talk to you again soon.